So the last thing I want to do with instantaneous velocity and average velocity is, can we figure out the instantaneous velocity for a linear function? So this is instantaneous velocity for a linear function. So let's call it s. Let's let s of t be m times t plus b. M and b are just numbers, so this is a linear function. And let's find the instantaneous velocity at t naught. So t naught is t with a little circle as a subscript. What that means is my starting point. So t naught is my starting point. So let's see. How could I actually do this? Well, the instantaneous velocity, remember that was approximated by finding the average velocity and getting closer and closer to t naught. So let's see what happens. So let's let t1 be close to t naught. And let's find out what is the average velocity between the two. Remember, average velocity between two points that are close to each other is approximately the instantaneous velocity. So it would be s of t1 minus s of t naught over t1 minus t naught. Well, what is s of t1? If I plug it into my equation, I get m times t1 plus b, and I'll put that in parentheses just so we can kind of make sure and keep up with all this. What is s of t naught? That's m t naught plus b, and this is over t1 minus t naught. Can I simplify this numerator any? Well, what happens if I distribute this negative? I'll get m t1 plus b minus m t naught minus b over t1 minus t naught. Well, my b's are going to cancel, so I get m t1 minus m t naught over t1 minus t naught. And now I could factor out an m for my numerator. So I get t1 minus t naught over t1 minus t naught. And these are going to cancel, so I'm just left with m. So what does that tell us? That tells us that the average velocity was m, regardless of how close I make t1 to t naught. So that means that the instantaneous velocity also has to equal m. So the instantaneous velocity is m. And it doesn't matter what my t naught is. For a linear function, the instantaneous velocity is always going to be m. So for example, let's let the position be given by 1/2 t plus 5. What's the instantaneous velocity at t equals 2? Well, since this is a linear function, the instantaneous velocity is always just m. That's the slope. So the answer here is 1/2. Again, I didn't give you units here, but 1/2. What about the instantaneous velocity at t equals pi? Well, it's a linear function. Doesn't matter what my original t is. The instantaneous velocity is always just a slope, so 1/2. So in general, when finding the instantaneous velocity, you're going to have to find the average velocity and kind of get closer and closer to my original point, unless it's linear. If it's linear, then you know the instantaneous velocity is just the slope, and that's the only function that we know at this point.